Hello? 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 All good? Hello, everyone. My name is Alexei Starovoitov, and it's the second time I'm speaking at this conference. It's absolutely a privilege. Thank you for inviting me again. I'm super excited to come back and talk again about BPF, but this time around, this presentation will not be technical at all. So it's for all audiences, including kids. So today, for the first time ever, I will tell a story of the technology that's now known under abbreviation BPF, how it was born, the challenges it faced, and by hopefully listening to the story, you will pick up a few tricks that I've used to, well, deceive maintainers, Dave and others, into accepting my poor patches. So what BPF stands for? Like in literature, it's considered to be a good practice to describe the abbreviation the first time it's used. That's what Stephen McCain and Van Jacobson did 30 years ago when they wrote that paper about BSD packet filter. Well, little they knew that in 2011, the startup will decide to revolutionize software-defined networking. That startup was PlumGrid. And I was the first engineer in this startup after first 3 founders. We started really early. The space was like buzzing. It was super hot. Just 6 months later, after we started the PlumGrid, Nisira back then was a pioneer of software-defined networking. They've created OpenWithSwitch, was acquired by VMware for $1 billion+. So everyone was super excited. We were iterating fast. Everyone working 24/7. For PlumGrid, the end game, well, wasn't actually that great. Everyone lost money, but that would be a different story. Back then, everyone was excited. Oops. So the idea to understand the rest of the slides, I need to explain a little bit what software-defined networking is. In pretty much virtualization was pioneered by VMware. Transition from physical servers into virtual. That's what virtual machines come about. In software-defined networking, that would be virtualization of the networking gear. The technology that powers virtual machines, traditionally called hypervisors. There are different examples of it, like KVM, KMU, Xen, proprietary. In software-defined networking space, at PlumGrid, we thought that the technology, the universal name for the technology would be I/O visor, as an analogous to the hypervisor. Well, the name, I don't think it really stick, but roughly to describe what we were trying to achieve. So this is your one Linux server. It has 5 different virtual machines, and they're connected. Every one of them potentially is protected by a firewall. The firewalls could be different for every one of them. Then they're connected by the 2 switches that provide layer 2 connectivity among them, and by layer 3 router. It would be very analogous to the physical world, where you have like actual servers, top-of-the-rack switches, and further down like backbone routers that create the whole networking topology. The idea of the software-defined networking is to virtualize the whole physical setup into virtual and put all of these physical components as virtual devices inside the Linux server. The traditional approach to implementing this solution, of course, like starts with KVM. KVM was already there, but for every virtual like router and switch, there would be a separate kernel module. At PlumGrid, we actually took a different approach, but some other startups that were also like super hot at the time, for example, it was Contrail. They actually had exactly that. They had vRouter kernel module. They even came and presented at, I think, at Plumber's conference right around that time. But at PlumGrid, we decided to do it differently because everyone's super excited. The space is hot. Everyone working 24/7. So having one kernel module that does like a fixed function was just not practical because everyone was trying to implement the new way of doing like firewalling, different, faster, different kind of routing, like load balancer, NATs, shapers, and so on and so forth. So there was so many different components, and we thought that even third parties eventually will be providing these plugins into this iVisor component, writing their own firewalls. And we wanted these features, these little building blocks, to be pushed remotely by centralized controller. So this, and the way we did it was we just compiled into native x86 code outside on the remote machine and pushing this x86 binaries down into the servers. Well, you ask what can go wrong. So in our case, when we developed this feature, we started running it, we started using it, and after 4 gigabytes of traffic, the servers would be crashing. And 4 gigabytes felt like, well, there must be something special about this number. Must be 32-bit overflow. So we've spent like a week looking for all the places where 32-bit overflow can happen. If we didn't find it, then what else? There must be some race condition why it happens. That took another like a week. And well, the answer was the M-no red zone. Is anyone aware here that x86? Raise your hand if you know that x86 using M-no red zone. Okay, great. So like back then, that was 2012. I didn't know, and well, as you can see, this question was asked 7 years ago after I struggled through all of this stuff. So I found out it's a very hard way that x86 AMD 64 is called ABI actually allows compilers not to move the stack pointer before they write before the save register into stack. So when interrupt happens, and back then like Intel Linux didn't switch the stack for the interrupt, it would be reusing this. So anything that was the stack pointer wasn't moved, the interrupt happens, it just saves its own registers. When it returns, the registers are completely garbage. So it just happened that it was like happening around 4 gigabyte worth of traffic. So that made us clear that just pushing binary x86 blobs into the servers, it might not be such a good idea. So we've started, so that's how came the idea of verifying the code that's pushed down to the servers. That's when the verifier was born. And I've been using this image of the verifier because like since then everyone hates it. This is this magic unpleasant hero that prevents your BPF programs being loaded, and it's very strict about it. But back then it was a necessity. When we started doing the verification, well, I quickly realized that x86 assembly is such a complicated beast. Variable instruction lengths, so many different, but variable instruction is not that bad, but amount of kinds of load instruction, the memory access instruction, the way that addresses can be combined is just like insane from the verification standpoint. So what we did, well, let's reduce this instruction set. So we hacked GCC to produce x86, but with less craziness in there and less variability. The performance will be potentially less, but it's fine. So that's what we had. So we had a verifier that was verifying this assembly, so it was like no JIT. So we didn't think of JIT at the time. It kind of worked, but we figured we will do better. So at that time, we went to version 3 variant of the iVisor. As you remember, I said it's a startup, everyone working super hard, let's rewrite everything, working 24/7, everyone's super excited. So we had this new instruction set, we had a different GCC backend that was emitting this special internal instruction set, was pushing it down into the module. Inside the module there was a verifier that was checking this instruction set, and there was a very simple JIT one-to-one from this instruction set into x86. And we didn't bother with interpreter because, well, who cares about interpreter? You need a performance that's networking. These programs that are processing networking traffic should be like really fast. So then it was an obvious decision, not even decision, it was a necessity. Like for a startup to be successful, the technology that it does has to be part of the upstream kernel. So we have to upstream this module. What we started doing, like the step, of course, is to talk to all the people who were willing to talk to us. So we spoke with compiler folks, with KVM people, with kernel people, And for every one of them, they came and said, look, we'll change the kernel, we'll put this thing in there, and we'll have a new compiler backend. And everyone looked at us and said, you guys crazy? You're going to change this two gigantic project to different communities? You're just like not going to happen. So like give up and well. So then we deployed this strategy. If something looks crazy, make it look familiar. That's very important point. So how we can make this new instruction set look familiar? What already exists? So started looking what's already there in the kernel. Back then it was BPF, IP tables, kinda instruction set, not quite, but there are structures. The filter tables, also more or less instruction set, and the net diag. I'm not, well, very few people even aware that it has also, it's another interpreter inside the kernel with its pseudo instruction set. Out of these possibilities, BPF looked the closest to the instruction set that we had. So, well, we had to make it look familiar. At this point, I didn't care. Like, the question asked in the beginning, what BPF stands for? Like, who cares? It's something. Let's make our stuff look similar to this. On the left side, you see the socket filter structure. This is encoding of the what's now known as classic BPF instruction. And the new one that we made, the only thing, if you look at that, you will see that the only common part that we managed to salvage and make it look familiar is opcode. So instruction opcodes is pretty much the only thing that is similar between classic BPF and this new one. But why not? Like, let's call this new stuff extended because well, that's what we're obviously doing. We're extending this whole thing. So, next step. Cannot push this kind of thing into the kernel, obviously. Like, no one will look at it. So what I did really, didn't tell anyone until now. Like for 6 months, the only thing I did, I subscribed to NetDev mailing list, and the only thing I did was reading it. Just reading all the patches, reading all the conversation, understand what the land, the politics, the turf that is there, like what people care about, like who are the people that I would need to convince. Then the next step, another trick that I've used is build a reputation. Though I was developing kernel since '99, well, none of my patches were public, so got to land the first one. So I've looked at logdep reports. I said, like, yeah, it looks like x86 is JIT doing something wrong. So my first official kernel patch that landed was really simple. The only thing it's doing here, it's moving the module free that cannot be called out of the with preemption disabled into the worker thread. That's it. That's the whole patch. But the key point here that Eric, who wrote x86 JIT at the time, well, had to review it, had to hack it, and well, Dave had to eventually applied it. So this was my first karma +1 karma point. A couple patches later, I fixed this race condition, which I guess I'm probably the most proud of out of my many patches since then. It was super painful. Like we were using network namespaces for testing, creating a bunch of network namespaces, destroying them, and we've hit this unregistered net device waiting for low to become free, usage count 1. Like if you've been doing kernel development, or not even kernel development, or doing anything like with not only network namespaces, this is such an infamous bug, message in the kernel that contributes. It means that this is reference leaks somewhere, and it can be like in anything inside the kernel. Like many different components at the end contribute that the reference count from that device doesn't go, from a loopback device doesn't get back to 0, and network namespaces cannot be destroyed. Many weeks later with the debugging, it did turn out to be a race condition, and the fix was, painfully simple, I guess. Well, probably for Dave who reviewed it then, he looks at like, yeah, that's obvious fix. For me, it was super painful. But that's a reputation, it keeps going. So now I felt that, well, I have some patches under my belt, so people probably know that, well, I can maybe do some kernel coding, so should I post a patch? Did it work? Nope. So it was simply rejected. So then I started thinking, like, why? Like, I thought, like, we're doing such a great stuff. Like, it's revolutionary technology. Like, what's wrong? So, and well, eventually I came to the realization that your API, this is the main concern, and this is the still concern that every maintainer has today in the Linux kernel. I have to stress, in the Linux kernel, not every community is the same. But for the kernel community, your API is such a bar because kernel like prouds itself that it doesn't break backwards compatibility. As soon as something lands and it exposes anything, is an API that stays forever. If it stays forever, it means that it cannot be removed. If it cannot be removed, meaning that the person who did it, it's now on the maintainers to like maintain this code forever, even this API is scrappy. Well, since your API is a concern, we need a plan B for this technology. So like how we can land something, this new instruction set, without exposing it to in user space API. The answer is find something to make it faster. So this is another trick I've used. Well, what can I find? There was an existing classic BPF interpreter in there. So what I did is ripped it out, replaced with the interpreter of this new instruction set. But the benefits of the instruction set, because it was like different, it only contributed roughly like 10% to the speed up. The rest of it was just a different implementation. The old classic BPF was just a switch statement, bunch of if conditions. Compiler was doing one jump, whereas in so-called jump-threaded implementation of interpreter, there will be indirect jump. Compiler can insert indirect jump after every instruction that it interprets. So when CPU executed, they just have a better branch prediction logic. So that's it. So like jump threaded implementation, that's what contributed this like 2 times speed up of the interpreter. And well, we cannot call it like extended BPF. It's not exposed in the API, so we've called it internal BPF. Why internal? There was, and at that time, like now we have like 2 BPFs. And Daniel Borkman came up with a brilliant name, I think. We decided to call the old one Classic. I still love this name. Like eBPF, I think, is a crappy name, but Classic BPF, I think, is brilliant. Classic says that it's something maybe a little bit ancient, like it shows the seniority of the instruction set of the old one, yet it's still not offensive. It still like looks good and sounds good. All right. So the status of everything of BPF things for the May of 2012, we had this converter from classic into internal interpreter that was now thankfully faster, and we managed to land it because like making things faster is a good enough reason to land patches. And we've converted by now all the JIT compilers, Spark, x86, ARM to operate now on this internal BPF instruction set. So notice eBPF doesn't exist yet. Verifier also is not in the picture at all. This is only what so far we did this changed. We changed the interpreter, we changed the JIT. So how do we apply this iBPF engine? So we proposed in this concept of the verifier that maps the helpers, and the whole idea, like the motivation came from the IO advisor, remember, the networking, the software-defined stuff, to run in native receive SKB hook. But we faced a ton of disbelief, let's say. The main one was that this instruction set cannot be extensible, that netlink and style, the NLA, utter, the type length value kind of encoding, folks believe that this is a more extensible solution, and especially they looked at the 8-bit opcode and say, well, sooner or later you will run out of these bits. You only can have like 256 instructions. What you're gonna do if you have another one? And I was trying to hand wave and say like, but we can have some other bits like somewhere, but it was not, well, resonating. Then the whole verifier story was like, what is this? This is doing some, like, it's not based on any theory, nothing like, I couldn't point to a paper and say like, this is how verifier works. This is like paper behind it. It's some code, but I guess the main, the most concerning part for this whole like BPF thingy was that it bypasses networking stack. Now, like many years later, it's not, like it's clearly not, like it plays together, like it reuses everything from the networking stack. But back then, that was the main argument. People looked and said like, this is bypass. And kernel bypass was a big like no back in 2014. So then brings me back to another trick that we used. Well, if we cannot, networking obviously was the main choice, but we cannot do networking, we have to compromise. So instead of doing networking, let's move everything into the tracing world, and well, we can apply this engine in the tracing. Actually, around that time, I've met with Brendan Gregg and said, look, like we can do this potentially, and he's like, well, yeah, it will be another dtrace. I'm like, yes, we can do that. So he got excited. And so I combined the two tricks here. First, like compromise. If networking doesn't work, try to do tracing, and again, make things look familiar. Filtering, like BPF, the classic BPF was all about filtering at that time. So let's filter this perf events. That's effectively what we did. We've created a pattern saying, well, if you have an event, we apply this program that will be filtering it. Which brings me to the point, again, to how to upstream patches. Makes the existing code faster. What is there? There was still the predicate tree walking mechanism that sort of works as a filter for the tracing events. So we said, look, if you apply this program there, if you let the program run there, it will be just a faster filter. It looks similar, it's doing similar filtering, but it will be like 2 to like sometimes like 10 times faster, depending on like how big is this predicate tree walker is. And now we're talking numbers, like hard numbers are very easy to like argue with, reason with the numbers instead of like some fluffy vision future thingy. Same thing, it's the same thing we did with the classifier. With the TC classifier, it has many different classifiers. One of the popular, let's say, ones at that time was UCT, so-called UCT2 classifier. It was like, again, mini kind of language bytecode that was interpreted. You read UCT2 numbers at the different offsets of the packet, and based on that, making a decision which flows potentially this packet belongs to. So again, attach a BPF program that show that it can do a better classification. So unfortunately, like at that time, we have to make a very nasty trade-off of clean design versus upstreamability. When we presented this stuff, especially for the K-probes as a filter, it's a filter for the K-probe. When it returns a 0, well, the K-probes will not be firing and will not go through the perf event. When it returns 1, it actually goes. So kind of looks normal, and for everyone who was looking at the patch, says, yeah, totally, that totally makes sense. That's what, of course, everyone should do. But we knew that it's really crappy. Since then, we've taught everyone when they're writing BPF programs that attach to K-probes, just return 0 always. And eventually, because it just makes no sense not to filter this stuff, because the whole purpose is to run the program that attached to a K-probe, not to filter it out. Well, that's what you have to do sometimes to land patches. Thankfully, so we keep pushing, and on September 26, 2014, Dave was kind enough to apply patches, and that's the day when the eBPF was born. So we're celebrating this day as official birthday of the BPF since then. It was like really like hallelujah moment. Everyone was so excited inside the Plum Grid, like we've celebrated. It was a really big deal, not only for me, not only for Daniel Borkman, who we worked with very closely by now for a year, but for the whole company. Like, it's often for the maintainers. When maintainers apply stuff, well, now I'm kind of in this role. Like, we don't like really like feel the people that are the other side of the fence, the joy that they have when the patches get applied. It's something that we should, I think, like always remember. I kind of rewind myself back into the 2014 and the feelings of like satisfaction. It's like, yes, that we did it. So every time I apply patches, somebody else patches now, I hope I make somebody happy with this, like, applied. Click of a button. But BPF didn't quite was useful at this time. So only like notice that the main patch set was applied September, and the first time it was actually useful is in December, when eBPF programs were could be applied to sockets. Again, same concept, make something look familiar. There was already a way to attach classic BPF programs to a socket to do the filtering. That's what TCP dump is using. The only thing we did is to allow eBPF program, extended program attached to it at the same place, at exactly the same spot, no new hooks. It looks familiar. Motivation was, well, maybe TCP dump will be using that. From the startup point of view, it was a useless feature. Then there was the classifier, attaching to the classifier, and finally to the kprobes. The kprobes was probably the most noticeable moment, I would say revolution in the programmable tracing. This is March 2015. Pretty much immediately after that, the BCC project started. They've created all of the tools later, and BPF trace, I think, started like couple months afterwards. So that was the beginning, I would say, of the programmable tracing, which was really cool, I think. So looks like kernel is done, right? So like they have the engine, we cannot attach in many different places. So are we done? Well, it turned out not, and we knew that this is just the beginning. Kernel is not only the community, not the only community we had to upstream the changes. Remember, we had a compiler, and we had GCC compiler at that time, who was generating this instruction set. But I will talk to it about later. The approach was to actually make a LLVM backend and try to do it. So we've used the same stuff. First of all, I probably should talk the differences between like kernel community and LLVM. Unlike the kernel, in LLVM, pretty much every developer has commit rights. They can just like push stuff into the kernel, and everyone can revert somebody else's commit, and no questions asked, more or less. Like in kernel, it's just like unthinkable. Like if maintainer pushes this stuff, somebody need to argue to revert something, and reverts are rare. In LLVM, like reverts are like left and right. Somebody pushed stuff, and well, it wasn't sufficiently reviewed. Revert. Other than this, it's similar. In kernel, there is a maintainers file. In LLVM, there is a code owners. Similar people roles. But there were like things like they were still on SVN. Now LLVM is using Git, like everyone else. They're still using Fabricator, so the whole code review is completely different than C++ versus C. It's a minor. What LLVM didn't have is UAPI concerns. Compilers and journals are changing a lot, and LLVM folks were absolutely fine. Like I was arguing, like, look, this BPF instruction set, it's part of the kernel. Like we will not be changing it. They're like, we don't care. You can keep changing it as long as you like. Like it doesn't matter. It's not. There's no API kind of that compilers provide. And another part was interesting. Like dealing with kernel so much, I felt that kernel community must mean something. I was arguing that, look, it's in the kernel. They're like, we actually hate you guys. Like LLVM folks like told me straight that they told Linus never to show up to LLVM mailing list because he's a jerk. They don't like, well, back then, it was about 2015, they didn't like kernel people. Now situations has changed, and I was trying to, well, to one leg in the kernel community, another leg in LLVM to bring the communities together. Was fun and challenging. What helped a lot is LLVM had regular monthly meetups in Mountain View and Tight House back then. Since then, like in 2019, this brewery is closed, so they've changed, and now they have this monthly meetup in Cambridge as well. So this is a way of engaging. It works very well. I think if I was not going and drinking beers with all the key folks in LLVM, I would never be able to land this patch. So that's another tip. If you can find this somewhere, that's your way. Another interesting bit that in the kernel, like testing and continuous integration, like we've seen the talks yesterday, and there will be one today about kernel testing. In LLVM, testing is first, like it's mandatory. The build bots are running non-stop. They're running, unfortunately, after most of the time, after the patch is landed. That's why patch lands, some build bot says, well, I have a failure, and the patch gets reverted. So that happened to me, like when I first landed the patch. The same, so I've tested it as much as I could, did the push, because like it's always scary to say like you push something, and then like a couple hours later Windows build bot like said that no, it doesn't compile with like Visual Studio or something, and like immediately some guy just reverted my change. It happens. Then in December 2014 I was brave enough to send this jumbo patch. Unlike kernel, like in kernel, we could split the changes into small, like reviewable pieces. Here it was one 4,000 line change. It was insane. It was difficult. It took 2 months, and all of these people have to ACK equivalent. In kernel, that would be equivalent of ACKing. ACKing this Jamba patch, if you like know, well, maybe you recognize some of these names. These are really like top folks in the LLVM community. I've had to like work with them all, and even though like so this 2 months of like non-stop like ongoing cycles and code reviews and respins of this diff, eventually it landed as experimental. That's another difference versus kernel. In kernel, when we land stuff, it's pretty much there unless somebody really argues about reverting. In LLVM, they said, okay, fine, like your backend looks like a toy. So it still looks like a research, and we don't care that it's there in the kernel. It's a research project. So here's the rules of like landing experimental backend. If there are no users, if we don't see that somebody is using this, we'll just rip it out no matter what. Like it can be like a month later, 2 months later, 6 months, it will be gone. It needs more than one developer. Like you've been doing all the code, not okay. Bring somebody else. And you must help with refactoring. So these were pretty much the rules, and refactoring happens all the time. As soon as I land stuff, like a week later, somebody was like changing something like a 3 wide. In kernel, 3 wide changes are rare. In LLVM happens all the time. Like people just go across all of the backends, changing everything, and often they don't, well, not familiar, and especially in this like newly invented instruction set, so you have to be there. All the backend owners have to be helping the people who are doing this core LLVM refactoring all the time. And buildbot, another part, the buildbot was mandatory. They said, well, if there is a backend, you have to contribute a buildbot. So we set up a VM, very beefy VM that was just like non-stop building and testing, and was part of this like common CI system where like the whole community is using. So going back to the GCC backend, so that we initially wrote, another interesting tip here is that being lazy might be a good open source strategy too. The backend we did for GCC was just a meeting binary because it was easy, and GCC has to do the plain text. So we figured, well, it's just too much work dealing with kernel, LLVM, potentially bin utils community, GCC community is just like too much work for the little startup. So we did nothing, and Oracle guys rewrote everything, and well, they landed. The bin utils, the BPF support in GCC is now there since 2019. They implemented BFD, they implemented assembler, they implemented stuff in the linker. They landed everything. So, well, Be lazy. So in the last part I want to touch about that maybe controversial is what I thought back then, that like I will just come and present this hypervisor concept, this BPF stuff. At the conference, I went and presented at Plumbers. Did it help? No. I'm not saying that don't do and present your future stuff. It's just what I noticed by looking at myself and many others. People go to the conferences, they presented their like future work, their ideas, and somehow assumed that it will make a huge difference. It does make a difference, but this difference is tiny. At the end, patches talk and bullshit walks. You can be as describing this future of something, it just like doesn't work. And like I see it all the time, like somebody sending now like BPF patch and saying, well, look, but I presented to this conference, here's the link to this PDF. This is so great. It's useful, the presentation somebody, just to see like why the patches are made, but they're not giving patches any more meat than the actual patches themselves. Code is what matters. And to summarize the strategies that may be useful to folks who want to implement their next crazy feature inside the kernel or any other community, start by learning the community. And the communities will be different, maintainers will be different. What people care in the kernel, they're different from LLVM. Then you cannot just like send the patches. You have to start by building a reputation. Start with patches in the areas where key people work. Like do something there, they will understand that you may be a capable programmer. And then the main things that I've used, look familiar, make the existing code fast, and compromise. I think these are the main three strategies that always work. Well, always. It worked in the BPF case. So that's what I wanted to say. Thank you, everyone.
So I will start. I found interesting that it's more a comment than a question, but I found interesting that you explained that you studied with social engineering to understand how to make your comment being accepted. And I think this is looping back with what Thorsten told us about how to make a good report or to interact with people, is first to understand how they work, to be well accepted, and to get the unconscious source code, the code of behavior of submitting. And I found it was one of the interesting part for me to explain everyone that they have to be patient before being accepted. It's not, you're not given everything at once. You have to learn and you have to be part of it to be much more accepted. So
Absolutely.
Thank you for making this clear and obvious.
First of all, amazing talk, really enjoyed it. But I had one question that's slightly out of scope. You talked about how to land the patches. I'm really curious about why you wanted to do all of this work upstream, because that's a choice that a lot of startups and companies that are building Linux products don't choose to do. So why did you make that choice to do all this work upstream?
That's actually the excellent question. So I fought hard inside the startup. The only people I had to convince is like CTO and CEO that we have to upstream. They initially didn't feel that it's like really necessary, but well, I knew that for technology to succeed, it has to be part of the kernel. And well, in the past, in the prior companies, I worked on kernel, Linux kernel as well, but all of these projects, many died and completely unknown just because they were not upstreamed. So I had this hard experience in the past doing something that I felt great, and once the project is canceled, that's it, you're gone. You can you will put it on a resume and say, yeah, I worked on the kernel, but well, no commits to show.
Great, thanks.
Ever feel like, was there ever a moment where you doubted it would go upstream? Like where you thought, fuck this, I'm out of here?
For sure. It was painful, especially and back then there were the other startups, there are other technologies, and Nasira was obviously there. So like OVS folks like saw like BPF as a threat, not only as a technology, but as a competition. They like politics-wise, it was challenging. And plus this vRouter and Contrail was thinking to do stuff. Then all the NetFilter stuff felt that it's also a threat for them. True or not, that's a different story, but there was enough competition in that area that it felt by all the participating parties that it's the same turf everyone is fighting for, which is not the case. But when people are threatened, they fight against you. So yes, I definitely feel down and doubted that it will ever happen, but perseverance, I guess, helps.
The interesting part is what I really liked about the talk, that it kind of makes obvious how much politics is actually involved in doing kernel development, because we always pretend like, oh, it's only about the technical approach and the technical arguments that you have, which is just true.
Exactly.
From the point of view, so from the Plum Grid point of view, the kind of a bit afraid, or did they fear a bit that the kind of proprietary technology will be open and available to everyone, including computers?
I'm not sure I understood the question. Are you asking whether I was worried about like maintainership, whether like the project will disappear?
From a company point of view, open sourcing some critical technology may be a bit frightening, because
that the company will pull the funding from the project?
Well, if they kind of give the tool to the competitors, they may have less to bring,
No, in terms of the founders, that the company would be worried that the same technology will be used by somebody else. Yeah, like that threat was obviously understood. That was pretty much the internal argument when I was pushing let upstream stuff. And the founders were like, well, yeah, it's our proprietary IP, but they knew, like, they were like waiting this, they were just like voicing it out that this concern is in the room when we were discussing stuff, but the weight to this concern was very small. At the end, it's about innovation. Who can like innovate faster using the same technology? And well, I guess the founders' concern were kind of right, because Plum Grid didn't go anywhere as a startup. But look at Cilium and Isovalent; they're capitalizing on a technology and like doing absolutely great.
Thank you.
How upfront were you being about your long-term plans while you were getting these patches in?
About my long-term plans. I was, and when I was presenting all of this, I was like, look, there will be like a big, bright future, and we can build all this nice stuff. But I would say it's not about, but like, no, pretty much it felt that at the end that this bright future is like everyone is ignoring. That's why I was saying, well, presenting and describing this stuff, I was upfront, but it's not about like how smart the people on the receiving side. It's not like they don't like capable of understanding. It's just they have like a different concerns, right?
Yeah. Okay. So a second question: how has this experience informed your own sort of conduct as a maintainer when you see patches coming from other people? Like, do you feel like it's made you more open to people wanting to do weird shit with BPF now?
Open. I would say we're totally open to people doing weird shit, but we have to walk before we run, right? So, in many cases, I don't know, let's take Benjamin at Hop in the room and like hit BPF as an example. Is it the level of crazy shit? Absolutely. And like you may be seeing like some folks saying, no, it's a knack, but it's great, I think. So the door is definitely open.
Yeah, okay.
On a similar line, you talked a bit about the compromise involved, and you've kind of focused on maybe the downsides of compromise. I wonder if you have any thoughts on the upside of the compromise, including, you know, some of the enabling of the crazy shit.
Interesting question. I need to think about it. But in few words, I would say the compromises are necessary. That was kind of my main point. It's more important to land patches, even if you feel like I felt and still feel that like some of the compromises that we made long term kind of suck. But it's more important to land them and let people start using them, because you can be wrong as well. Like here I probably like picked, and because it's kind of like more vivid in my memory, the bad compromises, but I'm sure in many cases the things I've compromised on, when the people said no, it has to be like this way, at the end turned out to be like really great. For example, it's huge, I would say, thank you for Andy Lutomirsky to convince me that everything and Daniel, of course, that everything in BPF have to be referenced by file descriptor, by NFD. Because the initial design didn't have any of the stuff. We had ID, just a pure like IDs for everything. When program gets loaded, ID. And he was like, no, you guys have to use the file descriptors. And I'm like, why? And he's like, this is why and why. I'm like, sure, why not? So like I made the change only because I was forced to, but pretty quickly realized that this was just brilliant suggestion. Like just community works, and code review, like this is an example where code review is just great, and having all the eyes on the project is awesome.
I wanted to say about the compromise aspect, and this is role reversal here, where you were the maintainer and I had to make a compromise on the initial approach, and actually it helped me a lot. Like I needed to get the thing done, right? And you had some ideas on the broader picture. I was hell-bent on one particular way of approaching it, changed it, it worked, it landed. So I guess compromises are not always bad. There's one thing that I think BPF does really well, and I think is reaching those compromises faster and not delaying them. Is there something you have recommendation for the other kernel maintainers or subsystems that could be applied broadly in the kernel community to reach alignment, or not saying compromise, but reach alignment faster between developers and maintainers?
It applies, I think, to like everyone. It's just like I'm not as familiar with other subsystems, so I don't really follow them that much. But I would say like number one principle of BPF is divide and conquer. And here I'm saying just split big ideas into small building blocks. The smaller the block is, the better it is. The more composable it is. It may be used for something else. And well, potentially we don't even know what it will be used for. One example would be BTF. When we added a type format, we're like, well, it will be part of the kernel. The kernel will be loaded in it, and everyone's like, what? Why do you need type debug information loading into the kernel? We're going to be wasting kernel memory with the debug information? Now it's like, yeah, of course. But back then, like, no. So because it was such a small block, just like, here's just type format. Well, you load it.
I think the BPF office hours, the video call office hours help a lot, because you get FaceTime with the maintainers, you understand their concerns. You don't have to wait for a conference or text to get the real context really soon. So.
Yeah, I agree. That worked. Unfortunately, it's not used as much. It's like once a month people request an agenda, but it's open. Every week we have a slot reserved. If anyone wants to talk like anything about BPF, we have every Thursday fixed slot. Please do. Thank you, KP, for reminding. Go ahead, sorry.
Thanks a lot for a very nice talk. One question I had is you did multiple iterations before you finally went with the final design, and every time they turned you down. Like for example, okay, this design doesn't work, you have to do something else. How did you keep yourself motivated, especially working in a place like startup where time is critical?
I don't know, being on a mission, and at least everyone in the startup, not just me, because I wasn't the only person working on it. Like Daniel Borkman, like he was in a different, he was at Red Hat at the time, and he shared the passion. So I guess it's a huge, like we became a team, and like since then been working together on it for so long, and just sharing that passion with somebody like helps you. So by sharing your like ideas, you grow yourself. So that's, I think, like why like startups and everyone should open up their ideas, because sharing the ideas make it bigger instead of smaller. Like hiding the IP, what most of the startups do, I invented something, this is my know-how. Actually sharing it will make it better even for themselves. So it all goes back in circles.
Just, this is repeating, I think, what some people have already sort of alluded to, but one thing I really like about BPF is that it's already proven that so much crazy shit is possible. Like the fact that the verifier can verify that loops are bounded. Like I would have assumed, hey, that's the halting problem. It's not possible. So they're definitely a nice lesson to be learned, I think, is that you can really redefine what's possible in ring 0 with something like BPF.
Yeah, absolutely. Push what's possible. It's all about innovation.
Thanks. So just as one of the latest crazy shit in BPF coming, I want to emphasize the BPF Office Hour, because it was great, because I submitted the first series and got your answer. I never interacted with you, and it was it's not that it was brutal, but they're always like, when you don't know the person in person, you never know if the intent was like, no, this is just not how you should be doing all this kind of stuff. And that immediately after you say that, yeah, there are the BPF hours, and I came here and you were just talking and telling me, yeah, this is great what you're doing and this kind of stuff. And this was really encouraging, and I think this is a great idea for any maintainers to be able to have this time that you can reserve with people who are doing stuff, so that they can actually have better understanding of what you're meaning in all of your patch series.
Yep. Thank you.
I'll tell a story that gives some background of what changed my mind on BPF, because initially I thought it was too crazy. Mm-hmm. So Alexei came all the way to Amsterdam for the NetFilter Summit, and to give you an idea, it's a really small conference of like not even a dozen people, and he came just to teach everyone about BPF. And so he said, oh, you can make this kind of switch with the BPF, and you can, I said, well, we already can do that. He said, well, we can make this other kind of switch. And I said, with small modifications, we could do that too. And this other type, and so on and so forth. But then I finally realized that the whole point was you could make all the switches with BPF, not just any specific kind. It was this kind of level of power that impressed me a lot about the idea, and like changed my mind for the better.
Thankfully, you did change your mind.
Thank you, Alexei.
Anyone else?
Thank you. Oh yes, and of course I have a slide 42. Well, I was stopping at 41 and figured I gotta make a last one.
Okay, thank you. We will be back at 2 o'clock. Okay, right. Have a good lunch.
And he shared the passion, so I guess it's a huge, like we became a team, and like since then been working together on it for so long, and just sharing that passion with somebody like helps you. So by sharing your like ideas, you grow yourself. So that's, I think, like why like startups and everyone should open up their ideas, because sharing the ideas make it bigger instead of smaller. Like hiding the IP, what most of the startups do, I invented something, this is my know-how. Actually sharing it will make it better even for themselves. So it all goes back in circles.
Just, this is repeating, I think, what some people have already sort of alluded to, but one thing I really like about BPF is that it's already proven that so much crazy shit is possible. Like the fact that the verifier can verify that loops are bounded. Like I would have assumed, hey, that's the halting problem. It's not possible. So they're definitely a nice lesson to be learned, I think, is that you can really redefine what's possible in ring 0 with something like BPF.
Yeah, absolutely. Push what's possible. It's all about innovation.
Thanks. So just as one of the latest crazy shit in BPF coming, I want to emphasize the BPF office hour because it was great because I submitted the first series and got your answer. I never interacted with you, and it was it's not that it was brutal, but they're always like when you don't know the person in person, you never know if the intent was like, no, this is just not how you should be doing all this kind of stuff. And that immediately after you say that, yeah, there are the BPF hours, and I came here and you were just talking and telling me, yes, this is great what you're doing and this kind of stuff. And this was really encouraging, and I think this is a great idea for any maintainers to be able to have this time that you can reserve with people who are doing stuff so that they can actually have better understanding of what you're meaning in all of your batch series.
Yep. Thank you.
I'll tell a story that gives some background of what changed my mind on BPF, because initially I thought it was too crazy. So Alexei came all the way to Amsterdam for the NetFilter Summit, and to give you an idea, it's a really small conference of like not even a dozen people, and he came just to teach everyone about BPF. And so he said, oh, you can make this kind of switch with the BPF, and you can, I said, well, we already can do that. He said, well, we can make this other kind of switch. I said, with small modifications, we could do that too. And this other type, and so on and so forth. But then I finally realized that the whole point was you could make all the switches with BPF, not just any specific kind. It was this kind of level of power that impressed me a lot about the idea and like changed my mind for the better.
Thankfully, you did change your mind.
Thank you, Alexei.
Anyone else?
Thank you. Oh yes, and of course I have a slide 42. Well, I was stopping at 41 and figured I gotta make a last one.
Okay, thank you. We will be back at 2 o'clock. Okay, right. Have a good lunch.